Okay. Looks like I'm just going to graph three rational functions here. The graph of a rational function, here are things about intersections with asymptotes. Okay, can I intersect an asymptote or can't I? The graph of a rational function cannot, will not ever, can't, won't ever, can't, cannot cross a vertical asymptote. The reason for that is, as we said in the definition, the graph's just not defined there. You're not allowed to put that x in. You can't get a 0 in the denominator. There's no y value that's possible. So for that reason, graph can't cross, can't do it. Now this is what's weird. The graph of a rational function can cross a horizontal or oblique asymptote. It can actually cross it multiple times. It's a weird scenario, but it happens. Because a horizontal asymptote isn't about what's happening here, it's about what happens out here. So it can cross as many times as it wants as long as it starts to head towards that number. Okay? List all asymptotes, sketch the graph. Here we go. Vertical asymptote. X equals -3. Whatever would make the denominator 0. Horizontal asymptote. It takes a little thinking, but you'll get used to it, and you'll actually like it. You'll be really good at this. I have an x to the 0 on the top and x to the 1 on the bottom. The x degree is higher in the bottom. That's y equals 0 all day. So I go y equals 0 as a horizontal asymptote. I go x equals -3 as a vertical asymptote. X equals -3. Now you can tell this looks like the parent function. It's been multiplied by 2 and it's been moved to the left 3, so it should be in the top right and the bottom left. However, I want you to get used to something. In order to figure out where this goes, you should plug in a point. So look, I'm going to put in f of -2. Now why did I pick that? It's just to the right of the asymptote. Am I going to get a point above, or am I going to get a point below this horizontal asymptote of y equals 0? That'll give me a hint at it is, should I graph it up here or should I graph it down here? So I put that in and I get 2 over -2 plus 3. That's 2 over 1. That's 2. I got a point -2, 2. Isn't that point kind of a suggestion that the graph isn't down here? It's up here. And it acts like the other one, so it's just going to kind of bend around those, those asymptotes. I went below. Shouldn't have done that. Should have stayed above that asymptote. My bad. Okay, and then we'll do the same thing on this side. So if that's x equals -3, I'm going to go on that side and we'll go like x, we'll go -5. Okay, so I have 2 over -5 plus 3. That's 2 over -5 plus 3 is -2. It's equal to -1. So at -5, 1, 2, 3, 4, 5, I have a -1. Isn't that point a suggestion that the graph isn't up here, it's down here? So just like we thought, this graph is up and to the right and down and to the left. Okay, now this one could be different because there's an x up top. That's just a number. So this is like the parent function 1 over x. It just got multiplied by 2, and then we moved it to the left 3. But this one's got an x up there, so it's tricky. However, I can go with vertical asymptote, just like I'm supposed to. Set this equal to 0, 2x equals 5, x equals a fraction. X equals 5 halves, which is 2.5, isn't it? So I'm going to go 1, 2, and then I'll just put a vertical asymptote right in between 2 and 3 and say that that's x equals 5 halves. Now, look at the x's. I got an x to the 1 in the top and an x to the 1 in the bottom. It's the same degree. If it's the same degree, go back to this part of your notes. If the degree is equal to, then it's y equals a over b. It's a fraction where I use the leading coefficients. So here we go. Horizontal asymptote equals y equals 4 over 2. Or, in other words, y equals 2. So I'm going to go up to y equals 2, and I'm going to draw y equals 2 as a horizontal asymptote. And now again, because that x is up there, I'm not sure if this should be top right and bottom left, or if it should be bottom right. It's definitely not going to be both here and here because that wouldn't be a function, right? On the right side, it's either above or below this horizontal asymptote, and on the left side, it's either above and below, but it can't be both. So check a point. Look, a real easy one to put in is 0 for this left side, so I'm going to go f of 0. And what do I get? 4 times 0 over 2 times 0 minus 5. That's 0 over -5. F of 0 is equal to 0. So I'm at the origin. Isn't that a suggestion that the graph is not up here, it's down here. So I'm going to stay below this horizontal asymptote of y equals 2, go through that point, and then I'll go down towards the vertical asymptote. Okay, and then on the right is 1, 2.5, 3. I'll put in like 3. 3 is to the right of 2.5, isn't it? So I'm going to go f of 3, and I get 4 times 3 in the top, and I get 2 times 3 minus 5 in the bottom. That's going to be 12 over 6 minus 5. That's 12 over 1. There's a point 312 on this graph. So if I go to 3, I'm all the way up at 12. I'm way up here. Isn't that a suggestion that the graph is not down here? It's up here. So it comes along this asymptote, takes a right, and hangs out above y equals 2. All right, last problem for the day, people. Last problem for the day. Vertical asymptote. Whatever would make the denominator 0, that is x equals 0. I have a vertical asymptote at x equals 0. Okay, looking at the degrees, this is a degree of 1, that's a degree of 2. Here it is, people. It is the slant asymptote. It is not horizontal, it is oblique. So how do I find it? I'm going to leave this space for a second, and I'm going to do myself some division. 2x dividing into 4x squared minus 5. Well, I'm going to multiply by 2x to make that happen. So I get 4x squared. I'm going to subtract that. These cancel. I get minus 5. And I can't divide that into there. That's a remainder. So my horizontal asymptote is y equals 2x. But it's not a horizontal asymptote. It's a slant asymptote. Okay, so there's 0, 0. I'm going to go up 2 and over 1. Up 2 and over 1. Up 2 and over 1. And I'm just going to put a whole bunch of points because I'm not that good at graphing a line freehand when it has a slope of something like 2. Apparently I can't even put dots there. What an idiot. Okay, so there we go. So I'm going to make my dotted slant asymptote. You guys see what I'm doing there? That's my dot. I'll make it go until the end at x equals 10 and x equals negative 10. That's what my asymptote looks like. Doesn't look like a perfectly straight line because I'm a terrible math teacher, let's be honest. Okay, so I need to figure out what's going on here. Look, on the left side, if it's going to be above this, this is what it would look like. It would come down on the left side, and then it would continue to follow this line. It would go all the way down here. It wouldn't start to go over here because we don't have a horizontal asymptote. It will follow the slanted asymptote. Now on the right side, it's either going to be up here, and then it would turn and go along with this asymptote. It would do that. Or if it's below, it'll start down here, and it'll just stay underneath that asymptote and go there. So we just need to pick a couple of points and see what's going on. I'm going to pick negative 2 and see what happens. F of negative 2 is 4 times negative 2 squared minus 5. It's times 2 times negative 2. Okay, this is 16 minus 5 over negative 4. 16 minus 5 is 11 over negative 4. That's negative. That's like negative 2. That's almost negative 3. So when I put in a negative 2, I got negative 1, 2, 3. I'm all the way down here. Okay, but I'm having a hard time telling, is that above or below? So the secret is pick something closer to the asymptote. So I'm going to pick negative 1. I'm really mad at myself for picking negative 2 right now. If you go too far away, you're going to be real close to the asymptote. You can barely tell. Okay? So I'm going to pick negative 1 and see what happens. 4 times negative 1 squared minus 5 over 2 times negative 1. That's going to be 4 minus 5 over negative 2. It's positive 1/2. I put in a 1, I get a positive 1/2. That negative 2, 1, 2, 3 is actually just above that line. So look what it looks like. It comes down on the left side of this vertical asymptote. It hits this point, and then it just stays above that slant asymptote. Now on the right, okay, it can't possibly be down here now. That's not for grabs anymore. It's what happens on the right. It's either also above, like this, or it comes down on the right side of this vertical asymptote and then goes up underneath. So I'm going to pick something real close again. I'm going to pick f of 1, and let's see what I get. 4 times 1 squared minus 5 over 2 times 1. 4 minus 5 is negative 1 over 2. It's negative 1/2. I put in 1, I got negative 1/2. That is definitely not on the line. It is an indication to me that on the right side of this vertical asymptote, over here, it stays below this slant asymptote. There is nothing up here. So it's going to go right on the right side of this vertical asymptote. It's going to hit that point, and it's going to stay just below this line of asymptote. That's what that graph looks like. You don't believe me? Go ahead. Don't believe me. I'll show you. I'm going to get rid of the one we had. Remember, these should be in parentheses. 4x squared minus 5 in parentheses divided by 2x. Okay, I'm going to hit zoom 6 and see if we don't see something that looks an awful lot like what I did. Too easy. All right, your homework will be on my math lab. Have yourselves a lovely day.